Okay, this is regarding a truss analysis. We have to determine the nodal displacement, support reaction, and element stresses using the Ansys workbench. Okay, so here you will see the picture. We have four nodes: number 1, 2, 3, 4, and also external forces are there: 30 kilonewton and 20 kilonewton, and the supports and 1 and 4 hinged support, and node number 2 is connected with the roller support, and the length of the member is also given, and here all the members are the same material with 200 GPa, and cross section is also same 500 millimeter square for all members. Okay, so we will see how to apply the Ansys workbench to determine these parameters: nodal displacement, support reactions, and element stresses. Okay, so we will go for the Ansys workbench, and then we have to go for a static structural. Double click on static structural, and if you want you can change this static structural, the title. For example, you are going for a truss analysis, so just you can type here truss analysis. Okay, as usual you have to go for engineering data, so go to the engineering data, and we can use the same default value for Young's modulus, because we will see here so here the Young's modulus is 200 GPa. It is same as our default value, so we can go for the same value. Okay, and Poisson's ratio is 0.3. Okay, so close this one. Next you have to go for geometry, right click and new design modeler. Okay, so go to look at, and we can go for the sketches, and we can on the settings. So I have to on the snap and 2D. Okay, grid spacing. Here also we will see it is comfortable to use millimeter. So I will go for major grid spacing as 100 millimeter. Okay. Now we can draw our structure. So what about our structure here? Yes, this is our truss. So we will draw using the line. Go to the line. And it is horizontal length is 1000 millimeter. So you know the major grid spacing is 1000, or just you can place anywhere. Then you can go for a dimension. Click here, H1 you have to change it as a 1000. Okay, now this become 1000. Again go to the line, simply click on anywhere when it is when it shows V. Again go to the dimension. So what is V2? 780, but it is 800 millimeter. So click here 800 millimeter. Okay. Now you have to complete the sketch. It's okay. Now it is finished. Next is you have to create a line body. So we are analyzing this using the line body. So go to the concept and lines from sketches, and all the members are the same property. That means Young's modulus value is same and the cross section area is same. So select all the lines. apply, okay, and then generate. Now a line body is generated, but you have to assign the cross section. So what about the cross section? Let me see here. It is mentioned the cross sectional area is 500 millimeters square. So if it is a square cross section, what will be the dimension? So that means you have to take the square root of 500. So you can select 22.361 into 22.361. Okay, so you will see here. Again, you have to go to the concept cross section, rectangular cross section. So it's a square actually. So 22.361 and 22.361. Okay. Now you have to assign this rectangle to this line body. So it's okay now. Here also same thing. You cannot see the cross section because you have to go to the view and you have to on the cross section solids. Now you can see the dimensions, cross section of the line body. Okay. So here it is over. Now you have to go for the next part. It's a model. So double click on the model. You have to wait. It is showing the show in progress. Okay. So what about the, you can go to the geometry and make sure what is the, go to the line body and you can see the material. Okay. Material is okay. Structural steel. And we have to go to the mesh and generate the mesh. Okay. Yes, mesh is generated with the default values. Now you have to go for static structure and apply the boundary condition. So what are the boundary condition? You have two hinge support and another one is roller support. So we will go for here, go to the fixed support, click here, apply. Again go for the next support, click here, apply. And the third one here, it is the roller support. So if it is, since it is a roller support, you have to go for displacement. So for a roller support, we have to go for displacement and select the point. And this is a two-dimensional and it can move only, roller can move along x direction. So it can freely move x direction, but y direction not possible. So you have to make it 0. Z component is also 0. So that means it can move only in the x direction. Now you have to select it. Apply. Okay, so we will see here 3 supports are ready. Now we have to apply the forces. So go to the force. Yes. So what is the force here? Let us see. Yes, 300 kilonewton is, sorry, 30 kilonewton is acting at the number 3 and 20 kilonewton is acting at number 2. Yes. So this is your point. Select this point and I will go for components. And it is acting y component minus, because it is acting vertically downwards, we have to put negative sign, and 30,000 Newton, and then go apply here. Yes. Now another force which is acting 20 kilonewton. So you have to go for the force here again. Again force here, and you have to go for components, and we have to put x component 20,000. Yes. So now the load is also okay. Force 30,000 and we have another force 20,000. So the boundary conditions and everything is okay. Now we have to go for a solution. So in the solution, what are the required? We need the total deformation, and also this time I need the directional deformation also. So I need the directional deformation in x direction as well as in y direction. So here you will see it is x-axis. So you have to select where you need the directional deformation in the x-axis. So you have to select the vertices. So I need the directional deformation here, here, and this vertex, and this one also. Now you can go for geometry, apply. So you will see the 4 vertices. I also need the deformations in the directional deformation in y-axis also. So here I have to go and select the y-axis, and then again I have to select the points. I need the directional deformation along y direction in these 4 vertices. So again you have to go geometry and apply. Okay. And also I need the stresses. Okay. So where is the stresses? We have to go for beam tool. Okay. The beam tool, you have the direct stresses. And also I need the reaction. Reaction is available here. Force reaction. Here I need the reaction. Here also I need the reaction. Then one more reaction is required. Where is it? At displacement. Okay. Now do this. Okay. So now everything is ready. We solved. Now we have to look at the results. This is the total deformation. So you can find out the point where you need the total deformation by simply, where is the probe? You have to go for probe. Yes. So here you will get the total deformation at the required point by using this. Okay. Now what about the direct deformation? This is the direct deformation, and also just I need, yes. So this direction deformation is along x-axis. So you will see here the blue color, it has 0 actually. So because this is the support there is no deformation. So 0 here, 0 here, and here you have red color, and this is the deformation along x-axis, and this is your value. Okay, this is in, remember this is in meter. So when you multiply with the 1000, you will get 0.19989 millimeter. And here the deformation at this point corresponding to the which vertex? Let me see here. Yes, number 3, joint number 3. This is your color. So this is the corresponding deformation. Similarly, you can also find out the deformation along y-axis. So this is the deformation along y-axis. So you will see here this is a red color because here also there is no, you will see here this is red. There is no deformation along this because y direction there is no deformation. These are the supports. Here also you have supports. Only deformation available at this point. Here you will see the deformation. Here it is downward, that's why it shown negative value. Okay. Now this is the direct stresses, and you will see the force reaction here. So force reaction 2 and force reaction 3. So force reaction, the value here. So this is in x-axis, the value is written here. And force reaction 2, you will see the reaction in x and y direction. And force reaction 3, it's a roller support, so it will be vertical reaction only, upward. So this is the value. Okay. And also you can generate the result also. So for generating the result, let me see here. Yes, you can go here, report preview, just click on here. Yes, now the report is generated, so you will see the values here. Okay, let me see our required values are here or not. This is the reactions, force reaction. So we have three supports: fixed support 2, and displacement. And you will see here, these are the reactions for the fixed support x-axis and y-axis. Here it is for the support to the reactions. Here for the displacement roller support, the reaction. Here in the roller support, x-axis. No. Okay, that's all. Thank you.